Algebra chapters 1.2 and 1.3. We're going to just review some fractions really quickly and talk about some number systems. Pretty basic, quick stuff. I know that you've seen fractions before. I don't want to spend a lot of time on it. I don't want to insult you at all. But I also know that fractions are a cause of concern for a lot of students. Something students can get overwhelmed with or feel nervous with when they come across them. So I'm just going to review the basic rules and identify when we do which. There's 4 scenarios to worry about: adding and subtracting fractions, multiplying fractions, dividing fractions, and solving with fractions. Notice how that fourth one, solving, is actually quite different than the first 3. The first 3 all deal with evaluations, or potentially simplifications, calculating what the fraction equals. Solving is a step with a variable involved. The first 3 aren't going to have a variable in them. The fourth one is. So be aware of that difference here. When you add or subtract, this is when you need a common denominator. And this is the only time you need a common denominator. Only common denominate if you add or subtract. So if I'm doing 2/3 plus or minus 4/5, I'll do minus. I want to get a common denominator, so I'm going to multiply. I know that denominator is 15. So multiply this by 3/3 and this by 5/5. I'm not going to go over how you can find denominators. If you want to talk about that with me at some point, we can. I expect at this point we can just get 10/15 minus 12/15, which in this case is -2/15. When you add or subtract fractions, you get a common denominator, and then the denominator doesn't change. It stays -12/15. That's different with multiplying. With multiplying, we do what's frequently called cross-canceling. It's probably not the most mathematically precise way to describe that, but if I have 2/3 times, I'll do 6/5 instead of 4/5. Well, I can just multiply across the top and multiply across the bottom. 2 times 6 is 12, 3 times 5 is 15, and then 12 and 15 can reduce because they can both divide by 3 to get 4/5. You're free to do it that way. You can just multiply across the top and multiply across the bottom. You don't need a common denominator. But what can make things simpler is if before you do your cross-canceling, before you do your multiplying, you recognize this 6 and this 3 have a common factor. They can both divide by 3. So if I divide them both by 3, 6 divided by 3 is 2, 3 divided by 3 is 1, then suddenly I'm multiplying 2/2 times 1/5, which is also 4/5, but a little bit faster and potentially less cumbersome to do the actual arithmetic. That's very helpful if you have lots of fractions. I could multiply the top and the bottom of these to see how big it gets. On the top would be 3 times 2 is 6, times 10 is 60, times 4 is 240. I could make this 240 over what I think is 810. I did that in my head, it might be wrong. And then reduce 24/81. Those can both divide by 3, so it's 8/27, and I think I'm done. But I could also recognize 10 and 5 can both divide by 5 to get 2 and 1. 3 and 3 can just cancel entirely. 4 and 6 can both divide by 2 to get 2 and 3. And then nothing else can cancel. And I have 1 times 2 times 2 times 2 times 2, which is 8. 1 times 3 times 9 times 1, which is 27. I have it that way also. So with multiplying, cross-canceling tends to be the most efficient and accurate method that I recommend you follow. I don't really care how you do it, so long as you're going to come up with the right answer. Let's talk about dividing fractions now. Here's the really great thing about dividing fractions. Never, ever do it. Now you might think that's a free pass to just skip all the division problems, but really what I'm saying is instead of dividing fractions, we do what's called flip and multiply. I don't like all these little catchy phrases because they can get confused, but the point is if you have 2/3, let's say divided by 6/5 again, I'm not going to try and divide 2/3 and 6/5. Instead, I take the second fraction, always the second fraction, and I flip it over and multiply. Never divide fractions, always multiply. Now I can cross-cancel again. 2 and 6 is really 1 and 3, and I get 5/9. 2/3 divided by 6/5 is 5/9. Okay, the last one is solving. Here is where we do what's called cross multiplying. And this is where I think things get confusing, because multiply says cross cancel, solve says cross multiply, divide says flip and multiply. There's a lot of the word multiply and a lot of the word cross, and these things can all get confused. So maybe this is where the catchphrases aren't so great, but just think, if I have 2/3 equals x over 6, I want to find this value of x. Well, I can just multiply both sides by 6 to get rid of this fraction over here. But the fractiony way we show this is we say we can make this 2 times 6 is 12, and 3 times x is 3x, and 12 equals 3x. Then just solve for x. 12 divided by 3 is 4. Notice how this is the only one where I was actually finding a value that for x that makes the equation true, because this is the only one where I had an equation. This was an expression, this was an expression, and this was an expression. Solving has equations that you have to find the value to make the variable give you a true statement. This is the sort of thing that if I were you and you struggle with this, I would make like a note card or a flash card, pin it up on my wall, and look at it all the time. Say, okay, add, subtract, common denominator, multiply, cross cancel, divide, flip and multiply, solve, cross multiply. And if you have something on your wall you can keep referring to, or like on the back desktop of your computer, or tattooed on your wrist, I don't really care, then you can always look at it and learn from it. And if it's always in the same physical space, when you're like taking a test in some other room, you can think about that space in your room at home or wherever you're doing your work and kind of remember that little poster you made yourself. And if you make the flashcard, you don't just print it up or copy it, then it's kind of in your fingers and kind of in your brain and much, much better than just screenshotting something or copy-pasting something. All right, there's your fraction review. I hope that's enough. When you see fractions, you can't hide from them. We're going to do them a lot in the class. We have to just deal with them. They're a big part of life. We'll talk about how big a part of life here. The main numbers that we deal with are called real numbers. I'm doing chapter 1.3 now. There actually are things called imaginary numbers, which I prefer to call complex numbers. We'll talk about those next semester. Let's talk about the real numbers. If there's a box of cookies and you're going to eat some, think of some possibilities. How many cookies could you eat? The obvious answer first is all of them, but that could be 1 or 12 or 3, or depending on how many cookies you have, it could be any of these. Here's what you probably don't think of. You probably don't think I could eat half a cookie, or I could eat 0.6 cookies, and you definitely don't think I could eat -3 cookies. You don't want to owe somebody 3 cookies or regurgitate 3 cookies you've already eaten. You don't think about root 5 or 12. That's because this class of number fits the setting of cookies. And different classes of numbers fit different settings of things that we're used to. If we talk about measurements or weights, that technically could be anything, right? Like something could weigh 2.837 ounces, although we might just say it's about 3 ounces. So we can be as precise or specific as we want with things that are being measured, which means it can go across any type of number classification. However, if we're just talking about things that appear in nature, like say we wanted to count the number of apples on the ground, we probably aren't going to be too worried about half an apple or a quarter apple. We're probably just going to say there's 1, 2, 3, 4, 5, 6, 7 apples. So all these number classifications matter because we think about them and use them quite naturally and quite frequently, so we want to be able to label them and discuss them with some precise definitions. So the first thing is a real number. And the best way I can describe a real number, everything inside this box is going to be a real number. Real numbers are all the numbers that you're used to dealing with. What I'm going to do is I'm going to kind of start inside and start working my way out. I'm going to be very, very specific when I start and then work my way out. So I'm actually not going to draw this box yet. I'm going to draw that last to make sure I have enough room for it. The first type of numbers that we deal with are called natural. And we deal with natural numbers as 1, 2, 3, 4, dot, dot, dot. 1, 2, 3, 4, 5, 6, 7, up and up forever. Sometimes they're called the counting numbers because it's how you count. When you count, you don't start at 0, you start at 1. They're called the natural numbers because it's what appears in nature. Go back to the apples on the ground. If we're going to say how many apples there are on the ground, we're probably saying that because there are apples on the ground, so we wouldn't say 0. 0 is a number that kind of came into existence after some thought and debate and discussion by, the earliest version of mathematicians, people who were just trying to figure out numbers in the first place. So the first set of numbers are called natural. After the natural numbers, we have whole numbers. No, that's not true. I'm sorry. Yes, it is. Whole. The whole numbers are the same as the natural numbers, but it also includes 0. So the way this box is drawn, if something is a natural number, if it's in here, then that means it's also a whole number. It's in here. So all I had to add for whole was the number 0, because the whole numbers are the natural numbers plus 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After whole is probably the first word you're not that comfortable with, but a very important one. Everything inside this box are called the integers. Integers are just positive or negative whole numbers. -3, -2, -1, 0, 1, dot, dot, dot. So I guess I'll put 1, 2, 3 just to make this clear. Integers are positive or negative whole numbers. So no decimals and no fractions, just those. If you're an integer, that doesn't mean you're a whole number. But if you're a whole number, you're definitely an integer. It's like how a square is a rectangle, but a rectangle isn't always a square. After the integers, we have a much, much bigger box. And these are called rational numbers. So the rational numbers include the integers, the wholes, and the naturals. -3, -2, 10, 0, 18. But it also includes fractions like 2/3, 1/5, -4/9, 3 1/4. And it includes decimals, 0.9, 2.73 repeating, 4.82. Rational has the word ratio in it. Every rational number can be written as a fraction of two integers. Like the number 0.87, I could actually write as the fraction 87/100. So if a number can be written as a fraction of two integers, it's a rational number because it has a ratio in it. There's a lot of rational numbers because every number that you deal with on a regular basis is rational, except for just a few non-rational ones. So over here in a whole separate box are the irrational numbers. If you're irrational, you're not rational, so you're not an integer, you're not a whole, you're not natural. These are primarily square roots of non-perfect squares like root 2 and root 3. See, root 4 is actually just 2, so that counts as rational and integer and whole and natural. But root 2 and root 3 are decimals that go on forever and never repeat. That's the primary characteristic of an irrational number. The decimal goes forever and never repeats. Other examples are pi. Pi is a number, 3.14159, that extends forever and doesn't repeat. A number called e that you'll learn about in this class, and some others. There's actually a ton of irrational numbers. I know this box looks smaller than this one, but it's not. I just, run out of space. All of these put together make up our beloved real number system. So all of these can fit inside this real number box. These are all the real numbers. And off to the side of those, if I wanted to, I could draw another box, and that would be called the imaginary numbers, or the complex numbers. Those are numbers that, honestly, you haven't really seen and understand because we don't express them with just these, 10 digits solely. There's other ways to express them. I don't know why I wrote it like that, but I did. So, there's your real numbers. Think about which ones classify in which ways. Understand that if you're rational, you're also an integer and whole and natural. Everything moves down. No, I said that totally backwards, so I'm going to delete that. Remember, if you're natural, it's also whole and integer and rational and real. So I could take the number -17 and describe that as an integer, a rational, and a real number. It's all three of those. But it's not necessarily whole or natural. In this case, negative 17 isn't whole and it's not natural. All right, that's all for today. Thanks for watching. See you next time. Okay, check this out. I've got two circles set up, but I'm going to have one of them spin faster than the other. This might be tough for me to get going, but here we go. I want to animate this point. Go. Animate. Start. Display. Animate. Resume animation. Okay, that's not it. I want this point to go faster. There it is. The point on the bottom right is going faster than the point on the top left, but they're both rotating around the same size circle. The point on the bottom right is going around 4/3 times faster than the one on the left. And it makes this kind of cool looking spirograph sort of thing. And it's like, looks like it has 3 dimensions, like it's just a bunch of rotating lines, like a physics, looks like a model of an atom maybe. But whoa, there it goes. For some reason it makes me hungry. I can't explain why that is, but I think most things make me hungry. Just so you know, if you like these videos, I got a lot more. They're covering Algebra 2 trig. I also got worksheets and curriculum and homework sets and all kinds of things you can look at. There's a link down below in the description. But this is pretty great.